Let's begin with the most basic experience of being alive. You are being pulled down right now. As you sit or stand or lie wherever you are, something is pulling you toward the center of the earth. You felt it every second of every day since the moment you were born. It is so constant, so relentless, so utterly inescapable that you've stopped noticing it. Gravity, not strong, like magnetism is strong, not dramatic, like electricity is dramatic, not fast, like light is fast. Gravity is the weakest of the four fundamental forces, weaker by a factor so large it defies comprehension, and yet it dominates the universe. It shapes galaxies, ignites stars, bends the paths of light itself. It is quiet and absolute and everywhere, and for centuries, humans have dreamed of escaping it. Anti-gravity, the idea that we could somehow cancel, reverse, or shield ourselves from gravitational pull. It is one of the oldest dreams in science fiction. Floating cities, hovering vehicles, objects that fall upward. The dream is intuitive because gravity feels like something that could be switched off, like a magnet that could be reversed. Brian Cox has spent his career studying the fundamental forces of nature. He has demonstrated in the world's largest vacuum chamber that a bowling ball and a feather fall at the same rate. He has stood on mountain peaks explaining how space-time curves, and he has been clear about one thing. Anti-gravity is not a technology waiting to be invented. Anti-gravity is a physical impossibility, not difficult, not impractical, impossible. And the reason goes deeper than most people realize. To understand why anti-gravity is impossible, you first need to understand what gravity actually is. And here is the thing most people get wrong. Gravity is not a force. I know that sounds strange. It feels like a force. When you drop a ball, it accelerates toward the ground, and that certainly looks like a force is acting on it. Isaac Newton described it as a force in 1687, and his description worked beautifully for over 2 centuries. But Newton himself was troubled by his own theory. His law of gravitation described how gravity behaved, but not what gravity was. It said that every mass attracts every other mass with a force proportional to their masses and inversely proportional to the square of the distance between them. But it couldn't explain how this attraction worked across empty space, instantaneously, with nothing connecting the objects. Newton called this action at a distance, and he found it deeply unsatisfying. He wrote that the idea of one body acting on another through a vacuum without any medium was, to him, so great an absurdity that he believed no person who had a competent faculty of thinking could ever fall into it. Newton gave us the mathematics of gravity, but he knew he hadn't explained gravity itself. For over 200 years, Newton's equations worked perfectly. They predicted the orbits of planets, the trajectories of cannonballs, the tides of the oceans. But there was always that nagging question underneath. How does gravity work? What is it? How does the sun reach across 93 million miles of empty space and pull on the Earth? What carries the signal? Then in 1915, Albert Einstein changed everything. He published the general theory of relativity, and it revealed something extraordinary. Gravity is not a force pulling objects together. Gravity is the curvature of space-time itself. Objects don't fall because they're being pulled. They fall because they're following the straightest possible path through curved space-time. The path itself is bent. Think about it this way. Imagine a flat rubber sheet stretched tight. Place a heavy bowling ball in the center. The sheet curves downward around the ball. Now roll a marble across the sheet. The marble doesn't travel in a straight line. It curves toward the bowling ball, not because the bowling ball is pulling it, but because the surface itself is curved. The marble is following the straightest possible path on a curved surface. That is gravity. That is what Einstein discovered. Brian Cox has explained this with characteristic clarity throughout his career. In general relativity, gravity is essentially the geometry of space-time. Mass and energy tell space-time how to curve. Curved space-time tells matter how to move. There is no force. There is no pull. There is only geometry. The Earth doesn't pull you down. The Earth curves the space-time around it, and your body follows that curvature. Einstein called this realization his happiest thought. He imagined a person falling freely from a rooftop and realized that during the fall the person would feel weightless. No force acting on them, no sensation of gravity at all. The person is simply following the natural geometry of space-time. It is the ground that interrupts this natural motion. When you stand on the Earth's surface, the ground is pushing you upward, preventing you from following your natural path through curved space-time. You feel heavy not because gravity is pulling you down, but because the ground is pushing you up. Brian Cox has a wonderful way of putting this. He says Newton would have told you the apple fell from the tree because gravity pulled it down. Einstein would say no. Newton accelerated upward to headbutt the apple. It sounds absurd, but this is what general relativity tells us. The falling apple is in its natural state, following the geometry of space-time. It is the ground and Newton's head that are being accelerated upward by the electromagnetic forces in the solid Earth, pushing against the curvature of space-time. This is not a philosophical distinction. This is a fundamental truth about the nature of reality. And it is the reason anti-gravity is impossible, because you cannot reverse geometry. You cannot make space-time curve the other way. You cannot create negative curvature that cancels positive curvature the way a negative charge cancels a positive charge. And here is the crucial point. There is no gravitational charge to reverse. This is the condemnation of geometry. Let me explain why this matters by comparing gravity to electromagnetism. Electromagnetism has two types of charge, positive and negative. A positive charge creates an electric field pointing outward. A negative charge creates an electric field pointing inward. Put them together and their fields cancel. This is why electromagnetic shielding works. Wrap something in a conducting shell and the charges rearrange themselves to cancel the external electric field inside. This is called a Faraday cage. It is simple, elegant, and based on a fundamental property of electromagnetism. Two types of charge. Now consider gravity. Gravity has only one type of charge, mass, and mass is always positive. There is no negative mass. There has never been any observation of negative mass anywhere in the universe. Every particle ever detected, every atom, every molecule, every star, every galaxy, everything has positive mass. Everything curves space-time in the same direction. Inward. Brian Cox has made this point repeatedly. In electromagnetism, you can shield, cancel, reverse. You have two signs of charge to work with. In gravity, you have one, just one. Positive mass, positive energy. Everything curves space-time the same way. There is nothing to cancel gravity with. There is no anti-gravitational charge. There is no material you can place between yourself and the Earth to block the curvature of space-time. This is not a technological limitation. This is not something that better materials or more advanced engineering could overcome. This is a feature of the geometry of the universe itself. Gravity cannot be shielded because there is nothing to shield it with. Gravity cannot be reversed because there is no negative gravitational charge to create a reversal. The condemnation of geometry is absolute. Space-time curves one way around mass, always inward, always attractive, and there is no counterpart, no opposite, no antidote. Let me put some numbers on this. The equivalence of gravitational mass and inertial mass has been tested to extraordinary precision. The Hungarian physicist Roland Eötvös first tested this in 1908 using a torsion balance, confirming the equivalence to about 1 part in a billion. Modern experiments have improved this to 1 part in 10 trillion. The microscope satellite, launched by the European Space Agency, tested the equivalence principle in orbit and found agreement to 1 part in 100 trillion. Think about what this means. We have looked for any deviation, Any hint that gravitational mass and inertial mass might differ, any crack in the foundation that might allow for something like anti-gravity. We have looked with instruments of staggering sensitivity, and we have found nothing. Zero deviation, perfect equivalence. To 15 decimal places, Brian Cox has reflected on what this means. The equivalence principle is not just a coincidence. It is telling us something deep about the nature of gravity. It is telling us that gravity is geometry. If gravitational mass and inertial mass are identical, then every object responds to gravity in exactly the same way. And if every object responds in exactly the same way, then gravity isn't acting on objects at all. It is acting on space-time itself. Objects just follow the geometry, and you cannot create anti-geometry. You cannot make a region of space-time that curves upward where it should curve downward. The mathematics forbids it. Einstein's field equations relate the curvature of space-time to the energy and momentum of whatever is present. Energy is always positive. Momentum contributes positively to curvature. The equations have no room for negative curvature caused by ordinary matter. This is the condemnation of geometry. Anti-gravity requires negative space-time curvature. Negative curvature requires negative mass or negative energy. Negative mass has never been observed. The mathematics of general relativity, confirmed by over a century of experiments, leaves no room for it. The dream of anti-gravity crashes against the geometry of the universe itself. And this is only the first condemnation. You might be thinking about antimatter. This is the most common objection, and it deserves a thorough answer. If matter has an opposite, antimatter, then perhaps antimatter has negative gravitational mass. Perhaps antimatter falls up instead of down. Perhaps antimatter is the anti-gravity material we've been looking for. It is an elegant idea. It is also wrong. In 2023, the Alpha collaboration at CERN settled this question experimentally. They created atoms of antihydrogen, each one consisting of an antiproton orbited by a positron. They trapped these antiatoms in a magnetic bottle, a carefully shaped magnetic field that held the delicate antimatter atoms in place, preventing them from touching any regular matter and annihilating. Then they slowly weakened the trap, releasing the antiatoms to see which way they fell. The experiment was extraordinarily difficult. It took 30 years to develop the techniques needed to create, trap, and manipulate antihydrogen atoms with enough precision to measure their gravitational behavior. The gravitational force on an individual atom is fantastically small compared to electromagnetic forces. Any stray electric or magnetic field could overwhelm the tiny gravitational signal. The Alpha team had to account for every possible source of error. The result was unambiguous. Antihydrogen falls down, not up, down toward the Earth. With the same gravitational acceleration as ordinary hydrogen, within the precision of the experiment, about 80% of the released antiatoms escaped through the bottom of the trap, consistent with gravity pulling them downward. The team found no evidence whatsoever for gravitational repulsion. Let me say that again because it matters. Antimatter has positive gravitational mass. It falls down, not up. The Alpha experiment measured the gravitational acceleration of antihydrogen to be about 0.75 g, consistent with the normal value of 1 g within experimental uncertainty. They found that the probability of antimatter falling upward is essentially zero. The experiment confirmed what most physicists expected. Einstein's general relativity, which was conceived before antimatter was even discovered, treats all mass identically. Antimatter and matter respond to gravity the same way. Brian Cox has discussed this result and its implications. The hope that antimatter might provide a shortcut to anti-gravity was always slim, but it was the last realistic hope within known physics. With the Alpha result, that hope is gone. Antimatter is matter with some properties: flipped, charge, baryon number, lepton number, but mass is not flipped. Mass remains positive, gravity remains attractive. Antimatter is not anti-gravity material. It is just material that happens to annihilate when it touches regular material. This is the condemnation of antimatter. The one known form of matter that might have had negative gravitational mass doesn't. Antimatter falls down like everything else. There is no known substance in the universe with negative gravitational mass. Every experimental test from Eötvös's torsion balance in 1908 to the ALPHA experiment in 2023 confirms that gravity is universally attractive. Now let me address the history of anti-gravity experiments. Because some people have claimed to observe gravitational effects that shouldn't exist. The most famous claim came from Eugene Podkletnov in 1992. He reported that objects placed above a rotating superconducting disk lost up to 2% of their weight. According to the story, someone in his laboratory was smoking a pipe, and the pipe smoke rose in an unusual column above the superconducting disk. This led them to investigate, and they reported measurable weight loss in objects placed above the disk. The claim generated enormous excitement. If true, it would have been one of the most important physics discoveries in history, a material that shields gravity. The implications for technology, for space travel, for engineering would have been staggering. NASA took it seriously enough to fund a replication attempt. Boeing reportedly funded a project called GRASP, Gravity Research for Advanced Space Propulsion, to investigate the claim, but it wasn't true. Podkletnov's results have never been reproduced. NASA funded a team at Marshall Space Flight Center to replicate the experiment. They built a similar setup, cooled it to the same temperature, rotated the disk at the same speed, and found nothing. Zero weight change. Other independent groups tried and failed as well. Martin Tajmar's group in 2002 also reported null results. Every attempt to replicate the effect has failed. Podkletnov withdrew one of his papers. He claimed that other universities in Toronto and Sheffield had reproduced his results, but none came forward to confirm this. The scientific community reached a consensus. There is no gravitational shielding effect from superconductors or any other material. The initial results were almost certainly due to unaccounted experimental errors, small effects from magnetic fields, thermal convection, vibration, or electromagnetic interference that mimicked a weight change. The upper bound on any possible gravitational shielding effect has been pushed down to less than 1 part in 10 trillion by lunar ranging experiments and precision torsion balance tests. Brian Cox has noted that this pattern repeats throughout the history of anti-gravity research. Someone claims an anomalous result. The media reports it breathlessly. Careful replication fails. The claim fades into obscurity. It has happened dozens of times, and the reason is always the same. Gravity is geometry. You cannot shield geometry. You cannot block the curvature of space-time with a superconductor any more than you can block the curvature of the Earth's surface with a sheet of aluminum. As one physicist at Vassar College put it plainly in Scientific American, simple shielding of gravity is not possible. Not only would it violate the laws of gravity, it would provide a perpetual motion machine, thereby violating the conservation of energy. This is a devastating point, and it brings us to the condemnation of energy. Here is why anti-gravity would violate conservation of energy. Imagine you had a material that blocked gravity. Place a sheet of this material horizontally above the ground. Place a ball above the sheet. The ball is now weightless, shielded from Earth's gravity. It floats. Now push the ball sideways, off the edge of the sheet. It falls, gaining kinetic energy as it descends. Guide it back under the sheet, and then back up to its original height. Because the sheet blocks gravity, lifting the ball on the shielded side requires no energy. You've just created energy from nothing. The ball gained kinetic energy falling on the unshielded side, and you spent no energy lifting it back on the shielded side. You can repeat this cycle forever, generating unlimited free energy. This is a perpetual motion machine. And perpetual motion machines are forbidden by the first law of thermodynamics. Energy cannot be created or destroyed. If anti-gravity existed, energy conservation would be violated and the entire framework of physics would collapse. Brian Cox has explained this connection between gravity and energy conservation carefully. Gravity is intimately tied to the conservation laws that govern all of physics. The reason you can't build a perpetual motion machine is the same reason you can't build an anti-gravity device. Both would create energy from nothing. Both would violate the fundamental laws that govern how the universe works. These are not separate constraints. They are the same constraint seen from different angles. The mathematician Emmy Noether proved in 1918 that every symmetry of physics corresponds to a conservation law. The symmetry of time, the fact that the laws of physics don't change from moment to moment, corresponds to conservation of energy. The symmetry of space, the fact that the laws of physics are the same here as they are a mile away, corresponds to conservation of momentum. These are not arbitrary rules. They are deep structural features of reality. If you could shield gravity, you could build a machine that generates energy from nothing, which would mean the laws of physics do change depending on where you are relative to the shield. The symmetry of time would be broken. Conservation of energy would fail. The entire edifice of modern physics would crumble. Every power plant, every chemical reaction, every nuclear process, every biological system depends on energy conservation. If anti-gravity existed, none of these processes would be reliable. The universe would be chaotic and unpredictable. This is not a minor point. This is the deep reason why anti-gravity is impossible. It is not just that we haven't found the right material. It is not just that our technology isn't advanced enough. Anti-gravity would break conservation of energy, and conservation of energy cannot be broken. It is one of the most fundamental laws of the universe, tested to extraordinary precision in every domain of physics, from subatomic particles to galaxy clusters. Nothing violates it. Nothing ever has. Nothing ever will. The condemnation of energy is the third verdict. Anti-gravity would create free energy. Free energy violates conservation of energy. Conservation of energy is inviolable. Therefore, anti-gravity cannot exist. The logic is airtight. The physics is clear. There is no escape from this argument, no advanced technology, no exotic material, no clever engineering can create a device that violates conservation of energy. Anti-gravity devices would do exactly that. Now, let me address a subtler problem. The problem of the graviton. In modern physics, forces are mediated by particles. Electromagnetism is mediated by photons. The strong nuclear force is mediated by gluons. The weak nuclear force is mediated by W and Z bosons. If gravity were a force like the others, it would be mediated by a particle called the graviton. The graviton has never been detected. This is not surprising. Gravity is so fantastically weak compared to the other forces that individual gravitons would carry almost no energy. Detecting a single graviton would require a detector so massive and so sensitive that building it might be physically impossible. But even though we haven't detected gravitons, we can deduce some of their properties from theory, and those properties tell us something important about anti-gravity. If gravitons exist, they would be spin 2 particles. This is a crucial detail. Photons are spin 1. The spin of a force-carrying particle determines the nature of the force it mediates. Spin 1 particles, like photons, can create both attractive and repulsive forces. This is why electromagnetism can be both attractive and repulsive. Like charges repel. Unlike charges attract, the spin 1 photon makes both possible, but spin 2 particles can only create attractive forces between like charges. This is a mathematical theorem, not a guess. If gravity is mediated by spin 2 gravitons, then gravity between any 2 positive masses must be attractive. There is no configuration of positive masses that produces gravitational repulsion through spin-2 exchange. The mathematics forbids it. Brian Cox has discussed the quantum aspects of gravity in the context of his research in particle physics. The spin-2 nature of the graviton, if confirmed, would provide yet another independent proof that anti-gravity is impossible. It is not just that mass is always positive. It is not just that space-time curves only one way. It is also that the quantum structure of gravity, the spin of the particle that mediates it, mathematically guarantees that the force is always attractive. This is the condemnation of quantum structure. Even at the quantum level, gravity is constructed to be universally attractive. The spin-2 graviton cannot mediate repulsive forces between positive masses. There is no quantum loophole. There is no clever manipulation of quantum states that could produce gravitational repulsion. The quantum nature of gravity, like its classical nature, forbids anti-gravity. Let me now address the objections, because when you tell people that anti-gravity is impossible, they always have objections. And some of those objections are intelligent and worth addressing carefully. First objection: what about dark energy? The universe is accelerating in its expansion. Something is pushing galaxies apart. Isn't that anti-gravity? This is a fair question, but the answer is no. Dark energy is not anti-gravity. Dark energy is a property of space-time itself, sometimes associated with the cosmological constant that Einstein introduced into his field equations in 1917, and later called his greatest blunder. It doesn't cause objects to repel each other. It causes the space between objects to expand. Think about it this way. Draw two dots on a balloon. Inflate the balloon. The dots move apart, not because they're pushing each other away, but because the surface between them is expanding. Neither dot is exerting a force on the other. The surface itself is growing. That is dark energy. It is not a force between objects. It is an expansion of the space that contains them. Objects in the expanding universe are not being pushed apart by a repulsive force. The space between them is simply growing. Brian Cox has been careful about this distinction. Dark energy creates an expansion of space. But locally, gravity still attracts. The Milky Way and Andromeda are still falling toward each other. The Earth still orbits the Sun. Apples still fall from trees. Dark energy operates on cosmological scales between galaxy clusters, where gravity is too weak to hold things together. It doesn't reverse gravity. It doesn't cancel gravity. It doesn't provide any mechanism for anti-gravity devices. You cannot harness dark energy to make objects float. Second objection: what about negative mass? If negative mass existed, it would curve space-time the other way. It would create gravitational repulsion. This is true mathematically. The equations of general relativity allow for negative mass solutions, but allowing something mathematically and having it exist physically are very different things. The equations of electromagnetism allow for magnetic monopoles. They've never been found. The equations of quantum mechanics allow for tachyons. They've never been found. Mathematical possibility does not imply physical existence. And there are good theoretical reasons to think negative mass cannot exist. In 1958, Philip Morrison showed that negative mass would violate conservation of energy in a gravitational field. In 1959, Leonard Schiff showed that quantum field theory effects would break the equivalence principle if negative mass existed. In 1961, Myron Goode showed that the existence of negative mass would cause certain particles, specifically the long-lived kaon, to decay in ways they don't. The kaon is a superposition of a particle and its antiparticle. If they responded differently to gravity, the kaon would behave in ways that contradict observation. Multiple independent theoretical arguments point to the same conclusion. Negative mass is forbidden by the internal consistency of physics itself. Brian Cox doesn't say negative mass is absolutely impossible. He is a careful scientist. But he notes that we have no evidence it exists, strong theoretical reasons to think it can't exist, and no mechanism for creating it, even if it could. Negative mass is not a technology waiting to be discovered. It is a mathematical curiosity with no physical counterpart. Third objection. What about the Casimir effect? The Casimir effect creates a region between two closely spaced metal plates, where the energy density is negative relative to the surrounding vacuum. Isn't this negative energy? Isn't this a path to anti-gravity? The Casimir effect is real. It has been measured. The energy density between the plates is indeed lower than the energy density outside. But this is negative relative to the vacuum, not negative in absolute terms. It is like a hole in the ground. The hole is below ground level, but it doesn't have negative altitude in any absolute sense. It is just lower than its surroundings. More importantly, the Casimir effect is extraordinarily weak. The force between two plates separated by 1 micrometer is roughly the weight of an insect distributed across a square meter. You cannot build an anti-gravity device from effects this small, and the negative energy in the Casimir vacuum is bound by quantum inequalities that prevent it from being concentrated or amplified. The quantum world imposes its own limits on negative energy, limits that prevent anything useful for anti-gravity. Fourth objection. We don't have a complete theory of quantum gravity. Maybe quantum gravity will change everything. This is the "we don't know everything" objection, and it is the most philosophically interesting one. It is true that we don't have a complete theory that unifies general relativity with quantum mechanics. Such a theory, quantum gravity, is the holy grail of modern physics. Brian Cox has called it one of the most important unsolved problems in science. But here is the thing. New physics typically extends old physics. It doesn't contradict it. Newton's gravity was extended by Einstein's general relativity, but Newton's equations still work perfectly for everyday situations. Einstein's special relativity was extended to general relativity, but the speed of light is still the universal speed limit. Quantum mechanics extended classical mechanics, but energy conservation still holds. The pattern of physics is that new discoveries preserve the core features of previous theories, while adding deeper understanding. For anti-gravity to be possible, quantum gravity would need to overturn the equivalence principle. The conservation of energy, the universally attractive nature of gravity, and the observed absence of negative mass. It would need to overturn not one but multiple foundational features of physics simultaneously. This has never happened in the history of science. New theories extend, they don't demolish. Brian Cox has been clear about this. We should be open to new physics. We should always test our theories. We should never stop questioning. But we should also be honest about what the current evidence says. And the current evidence accumulated over more than a century of precision experiments says that gravity is always attractive, that mass is always positive, that the equivalence principle holds to 15 decimal places, and that anti-gravity is impossible. The fifth and final condemnation brings all of this together. It is the condemnation of universality. Gravity treats everything the same. This is its most beautiful property and its most restrictive one. A feather and a bowling ball, dropped in a vacuum, hit the ground at exactly the same time. Brian Cox demonstrated this in NASA's Space Power Facility, the world's largest vacuum chamber, and it is one of the most striking physics demonstrations ever filmed. The chamber is enormous, over 30 meters tall, originally built to test spacecraft in simulated space conditions. They pumped out all the air, creating a near-perfect vacuum. When the ball and feather were released, they fell together, side by side, landing at exactly the same instant. The feather didn't flutter or drift, it plummeted like a stone. Because in the absence of air resistance, gravity treats a feather and a bowling ball identically. Their masses are different, their compositions are different, their shapes are different, but gravity doesn't care about any of that. Gravity pulls them at exactly the same rate, 9.8 meters per second squared, regardless of what they are. Einstein realized this wasn't a coincidence. If every object falls at the same rate regardless of mass, composition, or structure, then gravity isn't acting on objects at all. It is acting on space-time. Objects are just along for the ride. They follow the geometry, and the geometry treats them all identically. This universality means there is nothing special about any object's relationship to gravity. There is no hook, no handle, no property that could be exploited to make one object respond differently than another. David Scott demonstrated this on the moon during Apollo 15, dropping a hammer and a feather and watching them land together in the lunar vacuum. It was a beautiful confirmation of Galileo's insight from 4 centuries earlier. Everything falls the same way. There are no exceptions, no special materials that fall slower, no special substances that fall upward. The universality of free fall has been confirmed by every experiment ever conducted. And this universality is precisely what makes anti-gravity impossible. If gravity treated different materials differently, you might find a material that gravity pushes instead of pulls. If gravity had 2 charges, positive and negative, you might create a configuration that cancels out. But gravity doesn't discriminate. It treats everything the same, and what it does to everything is attract. There is no escape. There is no exception. There is no loophole. Brian Cox has reflected on what this means for our dreams of floating cities and hovering vehicles. Those dreams are beautiful. They've inspired generations of scientists and engineers and artists, but they crash against the geometry of space-time. They crash against the conservation of energy. They crash against the absence of negative mass. They crash against the quantum structure of the graviton. They crash against the universality of free fall. 5 independent barriers. 5 condemnations. Let me be clear about what we're saying and what we're not saying. We're not saying that humans cannot fly. We fly all the time. Airplanes, helicopters, rockets, but these don't cancel gravity. They use other forces, lift, thrust, electromagnetic forces, to push against gravity. The airplane doesn't eliminate the gravitational pull on its passengers. It generates enough aerodynamic lift to counteract that pull. The passengers still weigh exactly the same. They're just supported by a different force. We're not saying that objects cannot float. Magnetic levitation is real. Superconductors can levitate above magnets. But this is electromagnetic force opposing gravitational force. It is not anti-gravity. The superconductor still has weight. It is still pulled toward the Earth. The magnetic field is simply strong enough to push it back up. Remove the magnet and it falls immediately. We're not saying that weightlessness is impossible. Astronauts on the International Space Station experience weightlessness, but they're not free from gravity. Earth's gravity at the station's altitude is about 90% as strong as on the surface. The astronauts feel weightless because they're in free fall. They and the station are falling toward Earth together, following the same curved path through space-time. Einstein would say they're following geodesics, the straightest possible paths through curved space-time. They haven't escaped gravity. They're obeying gravity more perfectly than we are. Brian Cox has explained this beautifully. Weightlessness in orbit is not the absence of gravity. It is the purest expression of gravity. The astronauts are doing exactly what gravity tells them to do. They're falling freely through curved space-time. The sensation of weightlessness is what you feel when no force is acting on you at all. It is the natural state. It is the ground beneath your feet that creates the sensation of weight by interrupting your natural free fall. Gravity doesn't make you heavy. The floor makes you heavy. This distinction matters because it gets to the heart of why anti-gravity is a confused concept. People want to eliminate the sensation of weight. They want to float. They want objects to hover. And all of these things are achievable through various means: magnetic levitation, aerodynamic lift, orbital freefall, but none of them involve canceling gravity. Gravity cannot be canceled. It can only be counteracted by other forces or embraced through freefall. The verdict is clear. Anti-gravity is physically impossible. Not because our technology isn't advanced enough, not because we haven't discovered the right material, not because we need a breakthrough in engineering. Anti-gravity is impossible because the universe is constructed in a way that forbids it. Gravity is geometry, and geometry cannot be reversed. Mass is always positive, and there is no negative mass to cancel it. Anti-gravity would violate conservation of energy, one of the most fundamental laws of physics. The quantum structure of gravity, mediated by spin-2 gravitons, mathematically guarantees attractive forces only, and the universality of freefall means gravity treats everything identically, leaving no loophole to exploit. 5 condemnations. 5 independent lines of reasoning. 5 reasons why the dream of anti-gravity must remain a dream. Brian Cox has spoken about finding beauty in the constraints of physics. When you understand what is impossible, you understand what to focus on. And here is the liberating truth about the impossibility of anti-gravity. We don't need it. We have electromagnetism, which is 40 orders of magnitude stronger than gravity. We can lift ourselves off the ground with a pair of flimsy wings and a small engine. We can float trains on magnetic fields. We can launch ourselves into orbit. We can achieve everything anti-gravity promises through forces we already understand and can already harness. Think about what that means. Gravity is the weakest force in the universe. You can defeat it with a refrigerator magnet. Pick up a paperclip with a small magnet, and you are using the electromagnetic force of that tiny magnet to overpower the gravitational pull of the entire Earth. Every time you lift your arm, the electromagnetic forces in your muscles defeat the gravitational pull of a planet 6,000 kilometers in radius. With a mass of 6 trillion kilograms, gravity is weak. We defeat it every time we stand up. Gravity is not our enemy. Gravity is the architect of the universe. It gathered clouds of hydrogen into stars. It collected stars into galaxies. It shaped the cosmic web that stretches across billions of light years. Without gravity, there would be no structure in the universe at all. No stars, no planets, no moons, no life. Gravity made us possible. The very force we dream of escaping is the force that created everything we love. Brian Cox has dedicated his career to making people feel the wonder of the universe as it actually is, not as we wish it to be. And the universe as it actually is contains a force so elegant, so subtle, so perfectly constructed, that it holds galaxies together with nothing more than the shape of space-time itself. A force so democratic that it treats every particle the same, from the most massive star to the lightest neutrino. A force so fundamental that it defines the very geometry of reality. You cannot reverse this force. You cannot cancel it. You cannot shield against it. And perhaps you shouldn't want to. Because this force, this geometry, this curvature of space-time, is what makes the universe a place where anything exists at all. Without gravity's relentless attraction, there would be nothing. Just dispersing gas growing colder and thinner forever. No structure, no complexity, no life, no minds to wonder about anti-gravity in the first place. Look at the ground beneath your feet. Feel its solidity, its resistance. That sensation, the sensation of weight, is the Earth's curved space-time pressing up against you. It is geometry itself holding you in place, and it will hold you forever. Not because of a limitation in human technology, not because of a failure of imagination, but because the universe is built this way. Space-time curves. Mass is positive, energy is conserved, the graviton is spin-2, and everything falls the same way. Brian Cox knows this, physics knows this, and now you know it too. Anti-gravity is not a technology of the future. It is a violation of the laws that make the future possible. The same laws that prevent you from floating to the ceiling are the laws that lit the stars and shaped the galaxies and made this improbable moment of consciousness possible. And perhaps there is wisdom in accepting this. For centuries, humans dreamed of anti-gravity as an escape from weight, from effort, from the pull of the earth. But maybe the pull of the earth is not a prison. Maybe it is an anchor. Maybe the feeling of your feet on solid ground, of your body held in place by the gentle curvature of space-time, is not a limitation but a belonging. You belong here, the geometry of the universe says so. The ground will always pull you. The stars will always burn because gravity compressed hydrogen until fusion ignited. The planets will always orbit because space-time curves around the sun, and you will always feel your own weight. The gentle, constant reminder that you exist in a universe governed by geometry, shaped by curvature, held together by the weakest and most beautiful force in nature. That is not a limitation. That is home. The verdict is final. Anti-gravity is physically impossible. The geometry of space-time, the conservation of energy, the absence of negative mass, the quantum structure of gravity, and the universality of free fall all converge on the same conclusion. There is no escape from gravity. There never will be. And in that inescapable truth, there is something worth marveling at. The universe doesn't let you float free, but it does let you stand. It lets you stand on a planet beneath stars, inside a cosmos shaped by the very force that holds you down. And that is enough. More than enough, that is everything.